Now students, we are going to discuss question number 7.23, and in this question it is given to you a man stands on a rotating platform. Clear? Let's suppose we have a man, and man is actually stands on a rotating platform with his arm stretched horizontally, holding a 5 kg weight in his hand. Let us try to understand given situation. Let's suppose we have a rotating platform. Clear? And I am standing on this rotating platform. Let's suppose I have two weight in my both hands, and that platform is actually rotating like this. Clear? So at that time it is given, if I am considering myself as a platform, myself and platform, then the combined moment of inertia is given to you 7.6 kilogram meter square, and mass of each weight is also given to you, and the distance, initial distance is also given, that is 0.90 meter. Clear? Or you can say 90 centimeter. Clear? Now what will happen after some time? After some time we can see whenever I am folding my hand like this, now distance of that weight from axis of this rotation, now it becomes only 20 centimeter. Now what is my objective? My objective here is to find new angular speed. Now let us try to understand. So actually if I talk about important point, first I will find initial moment of inertia. Initial moment of inertia, I can say it is given 7.6 for a main plus platform. Clear? mr square, we can say 5 r, it is given 90 into 10 to the power minus 2 whole square. Clear? mr square, and multiplied with 2, because I have two hands and I am holding both weights in both hands. Clear? Yes. So now we can see from here you can write like this, 7.6 plus 10 multiply, I can say 90 divided by 100 whole square. We can say this one and this one cancelled out. So we can say 7.6 plus 10 into 9 into 9 divided by 100. Clear? We can say this one and this one cancelled out. Clear? So from here we can say 7.6 plus 8.1. Clear? So directly we can say 7 and this is 15. So I can say this is 15.7 and we can say kilogram meter square. Clear? So we can say this is initial moment of inertia. Clear? Now if I talk about final moment of inertia, at the time we can say 7.6 is a constant, but I can say distance from rotational axis of that weight is now changing. So I can say 5 20 into 10 to the power minus 2 whole square. Clear to you? So 7.6 plus 5, we can say this is 0.2. Clear? 0.2 into 0.2. Clear? So if you solve it, you can say 7.6 and we can say 5 into 2 by 10 into 2 by 10. This one and this one is cancelled out. We can say this is 0.2. Clear to you? Yes. Actually always keep in mind, here we have two weights. Clear? So we have to multiply it with 2 also. So this is 2 multiplied with 2. Clear? So now I can say here we are getting value 7.6 plus 0.4, and that is equal to 8 kilogram meter square. Clear? I can say 8 kilogram meter square. So this is final moment of inertia. Clear? Now it is also given, initially we have a rotational speed, that is revolution per minute. Always keep in mind this is given in a revolution per minute. You do not need to convert this angular velocity in radian per second, because it will be cancelled out from both sides. Clear? Now you can say this is a situation given to you. If I am talking about moment of inertia, if I am talking about moment of inertia about this axis, rotational axis. So on this rotational axis we can say net torque acting is equal to 0. Clear? It means I can apply here conservation of angular momentum. Clear? So I am just writing here two values, 15.7 and 8. That is important for me. So 15.7 and 8. Clear? So I can say I1, this is equal to 15.7 and we have this value 8. This value we have I2. Clear? I can write here for part number A, I1 omega 1, this should be equal to I2 omega 2. Clear? So value of I1, this is given to you 15.7 into omega 1, 30 revolution per minute, this should be equal to 8 multiply, I can say omega 2. Clear? So omega 2, I can say 15.7 into 30 by 8. Clear? So this one we have 4. Clear? And we can say this is 15. Clear? So now if you multiply you can directly say, or you can first divide it. We can say this is 3, we have here 3 left, clear. So 3 left, we can say that is 3.9, clear. So if you multiply it with 15, definitely you will get here values in revolution per minute. So we have 5, 13, so 45 or 13, that is 58. So 58.5 revolution per minute we are getting, clear. Clear to you? So we can say this is new angular speed, clear. Now important part, it is given is kinetic energy is conserved in the process. Generally you will find in this case kinetic energy increases. Why? Because as you are folding your hand, actually whatever your internal energy, that internal energy is actually converting into the kinetic energy of that platform, clear. Or we can also calculate here like this. If I am talking about K1 over K2 ratio, I can say 1 by 2 I1 omega 1 square divided by 1 by 2 I2 omega 2 square, clear. So value of I1 we know, that is 15.7 and that is 8. So 15.7 divided by 8 omega 1 is given 30 and this is 58.5. So 30 into 30 divided by, I can say 58.5 into 58.5, clear. So just take an approximation, I can say this is approximately 16, so I can say this is 2, clear. And let's suppose this is approximately 60, clear. So I can say 1 by 2 into 1 by 2. So from here we can say this one and this one cancel out and we are getting this ratio 1 by 2, clear. It means directly I can say value of K2 I am getting here, this is 2 times of K1, clear to you. So it means we can say kinetic energy is not same as before, clear. Actually kinetic energy increases, clear to you. We are getting the same result, yes. And actually why, from where that energy is coming, I already told you. Actually when we are lowering that weight, actually the work, or we can say the internal energy of our body, or whatever the internal energy we have, that is converting into kinetic energy of that platform, clear. So this is all about this question.